Hi and welcome back to the lab. Well, today on the bench we have a Kenwood TM-732 and this radio suffers from transmit problems, so intermittent transmit problems on both 70 centimeter and 2 meter. So that means it is not a problem, a known problem to the 2 meter power amplifier module, so it must be something different, and that sounds interesting. So let's have a look into it and let's see if we can fix it. Okay, so I've prepared everything so far. Let's start right into it. So let's fire it up. Oh, so the backlight is completely off, so that problem was not reported, but you clearly can see it, and it seems not to be loose connection or such. Okay, so that is a different story, and it is receiving, as you already can see. Let's see if it will transmit. Okay, therefore you can see the instruments, and so let's press PTT and we see it is on 10 watt, and yeah, both more or less agreeing on the power. Let me see on what it is set. Yeah, it's a medium, so that is right. Let's set it to low once again, and it is 5 watt. That seems to be fine as well. And let's see full power, okay, which is here 35 watt, so that both seems to be fine. Let's go over to 7 centimeter. 70 centimeters also set to full power, and that is you see there we have already a difference, so that is related to the wire. So here my millivolt meter is connected directly to the radio, and the communication service monitor has the wiring in between, and there you see what that already means. It is really a difference, a loss here for 70 centimeter for 431 megahertz on a normal easy wiring here. Okay, but I do not see the fault, so maybe it is heat related. But anyways, let me crack open the radio and let's see inside if something is obvious. Okay, and radio is open, and here we have our 145 megahertz PCB, and on the other side that is then of course the 70 centimeter PCB. So, well, you know, for me it already looks like that somebody was trying to reflow it here. So that is not known from Kenwood as factory standard, and we also can see it here at this connectors here. It all really looks like that something happened here. So let me flip it over and let's see what we have here. And okay, so what is that? So okay, so that looks to me that it has burned here, and it is somebody tried to reflow something here. And oh, look at the transistor here. So that is a switching transistor for transmit. So over this transistor the module and some other parts of the circuit gets TX voltage, so that is delivering voltage and of course the power for this process. But have a look here to the transistor. It looks like that it is backside front. So you see here that is the heatsink from the chassis, and can we see it maybe better? Let's see. What is that? So there, that looks like insulation, and that is not the original transistor in here. And you see that the front side of the transistor is here on the heatsink from the chassis, and the heatsink here from, you know, the transistor is backside, and that is definitely not the original transistor, I would bet. So something is already wrong here, and I mean, you see that it is quite dark and dirty here, so maybe that here we had in the past a problem with this transistor already, so that it has swapped out. And I know that the original transistor, which is from the factory mounted in here, is obsolete, so you cannot get it any longer, or not so easy, maybe somewhere in China, but it is not officially you cannot officially get it from Kenwood. So that is something we need to investigate a little bit more, because something definitely happened, and we see it at our antenna wiring as well. So that all has been soldered off, so that is definitely for sure. So that is an indication that it has been worked on before. But what I've just realized is that here the transistor itself, it's really going hot, especially when we transmit on 5 watts, so that means on low level. So I cannot really hold my finger here, so it is so hot. And yeah, I mean, that seems to be clear if you see how the transistor is mounted, so it cannot really dissipate the heat to the chassis heatsink, and so that would make sense. Okay, I just want to verify how high the temperature at the transistor really rises to know if it is alright, or if it is too high, because if it is too high, that could have already an impact on nearly everything. So until that maybe one leg will get out of the solder. So that is what we have seen as well. Anyway, so let's go here down to the monitor, where we want to check the temperature, and you see we are monitoring. Here is our transistor, and hope you can see it. We do have for the moment in time at our transistor 34.7 degree C. Okay, and now let's switch over to thermal mode, and now you can see even better that it is 34.6 C. Reference here is 38. Anyways, you see that I have tried to reduce the noise to the min, which means that here this purple, dark purple, represents 40 degrees, and here the yellow represents 100 degree. So that is how the setting is. Now I have set the radio, now I'm going to set the radio to transmit, and let's see what happens here to the transistor. If, yeah, okay, so it is coming up, so you see that the temperature is rising. I would say 65 degree is the maximum it should have, but what we see already that, come on, we are over 100 degree, and there you see what I mean. So that is really not how it should be. 110. I hope you really can see it. Let me try to go even closer. So I'm sure I can also set it to Fahrenheit, but I don't know where, so I don't use Fahrenheit. Never. So I'm sorry. Can I do it here? Maybe here. Let's see. Hang on, I try to set it to Fahrenheit. Okay, now it is set to Fahrenheit, 150 up to 300. At our test point we have 96.9 F. So sorry, I really don't know what it really means. So let me go closer to that. Let us do exactly the same. I'm now transmitting, and you see that it is heating up. I really do not have a clue what these figures mean, but you see it is coming up here. So maybe 150 was a bit too much at the low side, but anyways, you see it is still rising. So, and that is an FM radio, so it is normal that you talk and talk, that you tell your story. So that is not shortwave, where we go 5959, you know. So you see it is rising up 278. I will compare it with, so we are really going to 300 degree F, which is unbelievable. So that is definitely totally wrong, and that could be the reason for really anything what's going wrong with this radio. Okay, and I've set it back to Celsius, since sorry guys, I really don't know. I have no feeling what Fahrenheit means, but I see we are at 120 and it is still rising, and I would say a transistor which needs to dissipate power should not going higher to, let me say, maximum 65, 70 maybe, but that is then still or already a design error from my point of view. But we are here at 150 degree and still rising, so I really wonder why this transistor have not been popped up to now. So you see it is still rising. We are, by the way, here going with, can we see it, 5.2 watt output power, So that is what we have, and you see it is no joke. We are at 100, almost 170 degree, and I really stress it, because that is what really happens when you talk to your buddies on FM. So you are telling stories which might be going a bit longer. So that is normal, that is nothing special, and never ever you should reach at one of your components 170 degrees. So I'm calibrating it once again, just to see if it is changing, but it is not. So that is something we really need to look after. Okay, now we know why I was not able here to tap my finger on it and hold it there. It is incredible. So anyways, that means we need to take out here the PCB. We need to understand what it is all about. I mean, before we do that, we can have a look here on the... I have to switch off the radio. It is still on, and I take it off our power supply. And what I really wonder what has been used here. So let's see. Okay, that is the insulation here. Okay, so now I'm really curious. You may see it. So that has been a modified transistor. So let me see if we can read what kind. Okay, we cannot really see it, but it is a BD. So that is an European type, and that might have been a TO220 housing, not sure, but it looks like that it has been cut off here and then filed a little bit. So let me see, I have here a TO220 somewhere. So here we have a TO220, and you see it looks like that the heatsink from the transistor itself has been cut here, okay, and then has been put here in circuit. And I mean, the original one looks like a little bit like this one when it is cut. But anyways, here's a plastic housing, should not be at you know, the heatsink from our radio, because that then is not a good idea. So anyways, we need to replace the transistor, even if we do not get the original one, maybe. But I mean, it is nothing wrong with cutting it like it has done here, but we should have our metal side, which you can see here, of course, should be really lying against the heatsink. So therefore I really have to take out the board, and then let's see how it looks underneath. So I could think that you know, there is a problem with the solder joints due to the excessive heat, maybe. I mean, there are some other problems why a radio don't go to transmit. So that is very often here due to the fuse holders, because when they get loose and the contact is bad, then it receives, but when you try to transmit, then you cannot pull enough power through it. So that is always a fault source as well. So when you ever have trouble with transmit, that is something you should check as well. So now, and I've done it, so that is fine. So that means we have to take here the board out, and let's see how it looks underneath. So the board is out, and you see it is really a little challenge to get it out, because you really have to take apart the whole board, and you see here on the chassis that you have through connections which are really going here directly to the other side of the PCB, which you need to desolder, which is already not funny. Then you have here, where is it? No, you can see it here at the front panel. So that is sitting here in front of our housing. Okay, and you see that we have down here a connection which is here on the board. So you really have to take apart your whole radio, if you like. So that is a little challenge. And now we have the board, and we know here is our transistor, and when we flip it over, and I really believe that I am on the right trace. So you see we have here extremely bad solder joints, and maybe due to the excessive heat it has soldered it out a little bit by itself. I mean, it has been burned. We see that we have here a hole in the PCB, so that means that, well, it really has burned the old transistor, which was original in here. So it is definitely no fun, but on the other hand, really that is not a good work, to be honest. Okay, so here we can see much better under the microscope. So you see that we have here a hole inside the PCB. We can see that the joints for itself are not really good. Let me see if we can tilt it here a little bit. Yeah, you can see it much better here. So that is no good connection at all, as we see it here. I mean, as I already said, it is definitely not easy if you have something burnt on your PCB. I mean, that is for sure. But anyways, let's see. Yeah, I mean, we have to take it out in any case, since we know that it is getting too hot. So we really need to get the heatsink from the transistor really to the heatsink of the chassis, because otherwise we will be not able to get the heat away, and therefore, yeah, let's work through. So that is definitely not easy here, but I hope that we can finally get it somehow done. Okay, so as you can see here, in one point I was obviously completely wrong. So I grabbed here a photo from the inner of the 732, and what you can see here, so that is the original transistor. You see that of course it is a completely different type of transistor, the 2SD1902, if you like to see what kind of transistor it is, in a data sheet. And you see really that it is backside of the transistor is front. So the backside of the transistor is not laying back to the heatsink of the chassis. So that means that my assumption was a bit wrong, and well, still I really wonder why the transistor which has been put into the radio was getting so hot. Maybe it was the wrong type, or there is something else not really good in the radio, so I don't know yet. So the only thing I know is we need to replace the transistor, and I do not have the original type. It is obsolete, and it is very expensive if you can buy one. So we need to do something different. And as well here on the board, so you see that I have taken the transistor out, and what we can see now after the transistor is out, that the print here on the PCB shows that it is really that the back side of the transistor, as you see it here, so the lines here is indicating that the back side is front. So therefore, again, I wonder why the transistor was getting so hot. I believe maybe that it was a wrong type which has been here inside. So now we need to find a real equivalent type, and then let's try to get a new one in. Let's try to do finally the workmanship better. So do not see it where it is, over there, I believe, here. So we need to do the workmanship much better to be sure that it resists in any way, mechanically and electrically. So that is the aim. So let's see what the real equivalent type is, and then let's go ahead. Okay, let's check here the transistor in my trusty list. So you see that is the original one, 2SD1902. It is an MPN type, and you see here the datas, and we see that the equivalent one is a BD243C, and that transistor is here in bracket, so that means that the housing is different. So that is what we already discussed. But I think I should use here the BD243 because I have checked the data from the BD243, and that is already a better version. It is 6 amps, and therefore maybe it can better resist. So let's try that one. And I have here in my spare part, I have a BD243C, which you can now see as a type which would not really fits here into this situation, and that is the one we have taken out, and that means we need to cut here the metal as well, since it wouldn't fit here into the housing as the high is too much. So therefore we need to adapt it here a little bit, and then let's see how we can go ahead. Okay, so I have trimmed the new transistor in a way that we can fit it in, and I have here a new insulator for getting a good insulation between a collector and ground. That is a piece I have cut off, as you can see, and now let's see that we finally clean here the board as much as possible, and then let's see that we get the new transistor in. And well, if it still gets that hot, well, I really need then to think about the next steps we have to go. Okay, so as you can see, our new transistor is in, and well, I have tried my very best to get as much stability as possible, and on the second hand the best connectivity we need. So that is how it looks like after I have replaced the new one. I'm a little bit concerned, to be honest, about here this capacitor here, because it is so close to the transistor that finally you cannot really avoid that these both components are in contact anyhow. So, you know, maybe that this capacitor is really jeopardized by the extensive heat. So let me check minimum the ESR to make sure that it is within the tolerance. Okay, so let's try to get it here somehow in picture. So let's see. 0.7, approximately 0.8, and that is definitely in an acceptable range. So maybe because that is only the transmitter switch, and most of the time the radio is on RX, so that means that the heat is not constantly here at our capacitor. So therefore I would say that is fine. So it is not showing any huge problems, so we leave it as it is. Now let's try that we get it back in, and let's try or let's do the first testing after changing this transistor here. Well, I've cut out here a little copper plate which I want to put here in between to guarantee a better heat transfer. I mean, it is not the optimum we could do, but I really try to get as much heat as possible away here from our transistor. I put, of course, here some thermal component here between it to have it as best as possible, of course. Yeah, and that is how it looks like right now. So you see everywhere is a thermal compound, and by the little copper we placed in between, I hope that we really get the most possible heat transfer to the chassis. So that's how it is. Now I have to install everything back, and then let's see if it works. Okay, so everything is as we had it before. So back to the thermal test, and let's see if it makes any difference. So yeah, the settings are absolutely the same, and the radius set to 5 watt output power, because under that circumstances, as we have seen it before, the transistor has to dissipate the most heat. So therefore that is a setting where we can test it and where we have tested before. Alright, so let's now go to transmit and let's see what's really going on. And yeah, let me go a little bit closer here. And of course we see that the temperature is rising over our transistor. But I'm permanently transmitting, so there is nothing here what I hide. And you see it is still going up to 73, 76, 77, so that is Celsius, by the way. Don't get confused. I'm very confused when I see Fahrenheit, so sorry for that. But what we have seen before, that it was cranking up to over 170 degrees. And also I would say even 81, what we have now, and it is still increasing, as you can see. But it is much better than what we had before. I mean, it is not an idle situation when we only have the plastic housing, if you like, to the heatsink, to the chassis heatsink, so that is not idle. But as you see, with all what we have done with the copper in between, and with really everything, the heat, the thermal compound, and the real replacement type, it seems to be, now I pushed here the wrong button, and sorry, but anyways, just to show it here, it is definitely only 6 watt output power, so there is nothing wrong. Yeah, let me bring it back in and we can check it once again. So maybe we can do it here this way. So now transmitting, so you see the 6 watt on the instrument in the back, and you can see here where our transistor is, and of course it is rising. Yeah, maybe that is even better to see. It is rising, of course, but from my point of view there is definitely a change. So you can see the power in the background, 6 watt still, and we are reaching almost 80 degree C here at our transistor. But compare it with our first test here in the video at the beginning. So we have seen that it was very quick at 170 degrees, which is definitely a huge difference. Once again, I would not call it as perfect, but I believe it was a wrong transistor which has been in, and it was lousy done. So the craftsmanship was really bad, and now with the copper in between, with the extra thermal compound and everything, it looks like that it is better under control as it was before. And it looks like that it is not really going far above 82, 83 degrees. So I'm constantly transmitting. You see it on the watt meter in the background. And yeah, so it seems that it is able to hold the temperature because there is enough heat transfer to the chassis heat sink. So you really can see how much it matters, and I believe that was a fault, that with that high temperature really it simply switched off. And yeah, so that is definitely a difference here. Okay, I think it is enough testing. I think you can really believe me that it is not really going above 83, 84 degrees C. And yeah, I would say that is okay. So we can't change it anymore, but I believe that will last. I'm definitely sure. Okay, then of course we have still here our display, which is not illuminated. By the way, there you can see it also that both are set to low power. Anyways, there are always some who are very critical, which is fine, because we really need to make sure that everything is fine here. So we need to check here our backlight illumination, and yeah, then let's see if that is something we can fix easily. Then I hope that the radio is really back working fine. Right, and I've already here our front panel off and working on it. We will convert it to LED light. So that is what we do, because it is only one bulb less which is working. This one we have 4 altogether, so we swap them out. But what we found as well, that we have again here a capacitor which starts to leak. So that means we go and swap that capacitor also out, and then we should be fine with the radio. Wow, the leaking capacitor is off, and believe me, that was horrible. So the oxidation process by the acid was that far already gone to a state where, you know, it was really horrible to get it off. And you see how much really acid is here already on the board. I mean, not here at the side, so that is of course flux, but the black yeah, liquid in the middle, that is the acid. And the acid makes it really complicated to get fresh solder to the solder joint, since the adit is avoiding exactly that process. And that means you have really trouble to get fresh solder to the joint to be able to lift finally the component. And that is what it makes it so tricky. Okay, so yeah, the pads are more or less clean, so we can replace the capacitor. But then here are our bulbs, and down here. But we can't change easily to those LEDs here, which fits perfectly here into the hole. what we really need is to replace this 10 ohm resistor to, and here is already the new part, to a 390 ohm resistor. So that is always depending on the LEDs you are using, and two of these LEDs are in series, like our bulbs here. So that needs always an individual calculation, so you really need to do your own maths, but I have a video online where I have explained that, so if you follow along that video you know what you need to do. But now I take off all the bulbs here, and I replace, we have two, so we have one resistor there, and then there is another one which is this one here, which needs to get replaced as well to be able to fit in LEDs. Another nice thing is that this little holders here, the plastic holders, can be used for the new LEDs as well. So the only thing you need to do, of course, you have to take out here the defect bulb, and then you need to drill the holes here a little bit, since they are a little bit too small for the new LED leads. But that is quite easy. So you take a drill and you open them up a little bit, and then it really fits perfectly, and you can then easily put them back here into the radio, which is from my point of view absolutely perfect. Okay, so what we can see is everything is back in. So you see here our new capacitor, and we have all the new LEDs in and the new resistors, so everything is fine. And now let's put it back into the front panel housing, and let's see how it works out. Okay, everything ready for testing. Communication test has already switched on and dialed in the right frequency. So let's see what we have here. Wow. So have a look. That is really nicely looking. The new backlight illumination. So I really love it, as these LEDs turning out better than the original bulbs, so that is fantastic. Okay, so that is fine, and let's do testing for power on both 70 centimeter and of course 2 meter. Okay, so we start testing on 70 centimeter, but I take you over to the test set to see all the figures. Okay, so you see receive is really just fine, and yeah, let's start with low power, which is 4.6, which is fine. Frequency is okay. Deviation is working as well, so everything is really nice. Maybe we can do a short receive test. Just want to see minus 100, 20, 22 and still 20 dB sign-out. So we really do not need to see anymore. So let me go up to maximum power, just to be sure that there is everything good as well. 28 watt, 26, 28 on 70 centimeter is just fine, no problems whatsoever. So let me switch over here to 2 meters. We're still receiving on 70 centimeters. That is no problem, but now we need to see here exactly 145 and 4.8 watt. You already see that deviation is working fine. So let me go on full power on a 2 meter as well, and yeah, 31, that is just fine. Deviation is working also fine. Okay, so that seems to be fine. So I've tested it meanwhile for a longer time here on Transmit to test in all different temperatures, and radio was working fine. So I really believe that here our new transistor is really the game changer, but there is still of course a risk that it is still there. But anyways, I would say 90% it is fine. It has to go back to the owner. It needs to go back in a daily use, and then if really there is still something, anything around drops in TX, we have to look another look to it, but I really would think it is fine. So therefore I stop the video here. So you have seen really the whole process on fixing the problem on TX drops. I mean with 170, not 17, 70 degree C, it is nearly impossible for a transistor to work reliably. So therefore that's it for today. Thank you for watching, and catch you next time. Bye.